Hello dear students, in this video I'll continue with chapter 8 which is calculus. Here I will discuss about algebra of derivatives and chain rule and solve the questions of Check Your Progress 8 of chapter 8 from the student support material. I'll also solve some additional questions for practice. First we will see the algebra of derivatives of functions. If we have f and g be two functions such that their derivatives are defined in a common domain, then derivative of sum of the two functions is sum of the derivatives of the function. So first one is the derivative of sum of two functions is sum of the derivatives of the function. So here it is given f of x and g of x are two functions which are defined in a common domain. Then we have the derivative of f of x plus g of x. This is equal to derivative of f of x plus derivative of g of x. So d by dx of f of x we can write it as f prime of x or f dash of x, and derivative of g of x is d by dx of g of x, which is g dash of x. And the derivative of difference of two functions is difference of the derivatives of functions. So again we have d by dx of f of x minus g of x. It is equal to f dash of x minus g dash of x. That is, we have to, if we have the difference of two functions and if we want to differentiate that function, then we can differentiate each of these functions separately and find the difference to get the answer. Next one, derivative of product of two functions is given by the following product rule. That is d by dx of f of x into g of x. This is equal to f dash of x into g of x plus f of x into g dash of x. First we have to keep g of x as it is and differentiate f of x. Then plus keep f of x as it is and differentiate g of x. The next one, derivative of quotient of two functions is given by the following quotient rule. That is d by dx of f of x upon g of x. To find this derivative, what we have to do is, the denominator we have g of x the whole square, and in the numerator we have f dash of x into g of x. We have to keep the denominator and differentiate the numerator. Keep the denominator and differentiate the numerator, then minus keep the numerator and differentiate the denominator. This is called the quotient rule. That is d by dx of f of x upon g of x is derivative of the numerator f of x into g of x minus f of x into derivative of the denominator, which is g of x. The whole thing divided by g of x the whole square. So here are some of the rules that we can remember. First one is multiplication by constant. That is, if the function is c into f, then the derivative is c f dash. That is d by dx of c into f of x. This is equal to c into f dash of x. And next we have the power rule. Derivative of x raised to n is n into x raised to n minus 1. Derivative of x raised to n is n into x raised to n minus 1. Then the sum rule, this we just now saw. Derivative of f plus g is f dash plus g dash. Derivative of f minus g is f dash minus g dash. And then we have the product rule. Derivative of fg is fg dash plus f dash g. And the quotient rule. Derivative of f upon g is f dash g minus g dash f, the whole thing divided by g square. This rule also we just now saw. And lastly we have the reciprocal rule. Derivative of 1 by f is minus f dash upon f square. that is d by dx of 1 by f of x. It is equal to minus of f dash of x upon f of x the whole square. Now let us understand all these rules by finding the derivatives of some simple functions. The first one is find the derivative of the following functions. First one is 28. Now we just now saw the derivative of a constant is 0. That is, we just now saw a derivative of a constant c, it is equal to 0. So the derivative of 28, it is equal to 0. The next question, x square minus a, where a is a constant. Now the derivative of x square minus a, it is derivative of x square minus derivative of a. Now this we know it is equal to 0 since a is a constant, and then we saw another rule, derivative of x raised to n is n into x raised to n minus 1. So here the derivative of x square, we have already found derivative of x square, derivative of constant, all these using the first principle in my previous video I have explained. Again there also we will get the same answer. Here using these rules also we can find the derivatives. Using this, derivative of x raised to n equal to n into x raised to n minus 1. Here derivative of x square will be, here n is 2, so it is 2 into x raised to 2 minus 1, minus derivative of a constant term is 0. So this is equal to 2x. So derivative of x square minus a is 2x. Next one, derivative of x raised to 9. Again we just now saw derivative of x raised to n is n into x raised to n minus 1. So derivative of x raised to 9 is 9 into x raised to 9 minus 1. So it is 9x raised to 8. And then we have x raised to 4 plus x square minus 12. The next question. So derivative of x raised to 4 plus x square minus 12. It is equal to derivative of x raised to 4 plus derivative of x square minus derivative of 12. Now derivative of x raised to 4 is 4 into x raised to 4 minus 1 plus derivative of x square is 2 into x raised to 2 minus 1 minus derivative of a constant term is 0. So this is equal to 4x cubed plus 2x. So this is how we can use the algebra of derivatives and the rules to find the derivatives of various functions. And now we have derivatives of algebraic functions using chain rule. Now a function is a composite function if it can be written as f of g of x. And now we have, if f is a composite function, then the derivative of f with respect to x, it can be written using the chain rule. That is d by dx of f of g of x. This is equal to f dash of g of x into g dash of x. That is, we need to keep this function as it is and then differentiate to get f dash of g of x, and then we have to differentiate g of x to get g dash of x. So using chain rule, d by dx of f of g of x is equal to f dash of g of x into g dash of x. Say for example, let us take, let f of x is equal to 5x square plus 3 the whole cube. So here if we take f of g of x is equal to 5x square plus 3 the whole cube, then f of g is g of x the whole cube and g of x is 5x square plus 3. So here we can see that 5x square plus 3 the whole cube, it is a composite function of f and g, where f of g is g of x the whole cube and g of x is 5x square plus 3. Now if we want to find the derivative of this function, now to find f dash of x. So from here we have f dash of g is 3 into g of x the whole square, and g dash of x is, using the property d by dx of x raised to n is n into x raised to n minus 1. Here this n is this function g of x. So the derivative of x cube will be 3 into x square. So this will be 3 into g of x the whole square, and the derivative of g of x is the derivative of 5x square. This will be 5 into derivative of x square, and derivative of x square is 2x. Derivative of x raised to 2 will be 2 into x raised to 2 minus 1, so it is 2x. So g dash of x will be equal to 10x. Therefore, f dash of x is equal to f dash of g into g dash of x. So this is equal to 3 into 3. F dash of g is 3 into g of x the whole square. G of x is 5x square plus 3. So this is 5x square plus 3 the whole square into g dash of x is 10x into 10x. So this is equal to 30x into 5x square plus 3 the whole square. So this is how we can use chain rule to find the derivative of composite functions f of g of x. Now these are the questions from Check Your Progress 8 of chapter 8. Find the rate of change of area of a circle with respect to its radius r when r equal to 5 centimeter. So we know area of the circle is given by area A equal to pi r square. Now we need to find dA by dr. This is the rate of change of area of the circle with respect to its radius. Now dA by dr, it is equal to the derivative of pi r square with respect to r. Now this is equal to pi into derivative of r square. Now we know d by dx of x raised to n is n into x raised to n minus 1. So d by dr of r square will be 2 into r raised to 2 minus 1, or it is equal to pi into 2r. So this is equal to 2 pi r. Now it is asked find the rate of change of area with respect to its radius when r equal to 5 centimeter. So when r equal to 5 centimeter, this is dA by dr. dA by dr equal to 2 pi into 5. Let us take this as 1. This is from 1. So this is equal to 10 pi centimeter square per centimeter. So the rate of change of area of a circle with respect to its radius when the radius is 5 centimeter is 10 pi centimeter square per centimeter. Next question. On heating, the volume of a metal cube is increasing at a rate of 9 cubic centimeters per second. How fast is the surface area increasing when the length of an edge is 10 centimeter? So here it is given, it is a metal cube and the volume of this metal cube, it is increasing at a rate of 9 cc per second. We need to find how fast is the surface area increasing when the length of the edge is 10 centimeter. So let the side of the cube be a centimeter, then volume of the cube will be a cube centimeter cube. Given, let us take volume of the cube as V. Given dV by dt, this is equal to 9 centimeter cube per second. Now we can differentiate this V. So the derivative of a cube, this is equal to 9, which means derivative of a cube will be 3a square into dA by dt using the chain rule. This is equal to 9, or from here we have dA by dt equal to 3 by a square. Let us take this as 1. Now we need to find how fast is the surface area increasing when the length of the edge is 10 centimeter. So surface area, let us take it as A, it is equal to 6a square. Now dA by dt, it is equal to d by dt of 6a square. This is equal to 6 into derivative of a square. Derivative of a square is 2a into dA by dt. So this is equal to 12a into dA by dt is 3 by a square into 3 by a square from 1. So this is equal to 36 upon a. Now it is asked how fast is the surface area increasing when the length is 10 centimeter. So when a equal to 10 centimeter, dA by dt equal to 36 by 10. So it is 3.6 centimeter square per second. So the surface area is increasing at the rate of 3.6 centimeter per second when the length of the edge is 10 centimeters. Now these are some additional questions for practice where we have to use the algebra of derivatives of functions and chain rule to find these derivatives. Find some constants a and for some constants a and b, find the derivative of. First one, x minus a into x minus b. Now we have seen the product rule, d by dx of f into g, this is equal to f dash g plus f g dash. So using this, let us find d by dx of x minus a into x minus b equal to, first let us differentiate this. Now d by dx of x minus a will be derivative of, it is d by dx of x minus d by dx of a. Now we know derivative of a constant is 0 and derivative of using d by dx of x raised to n, this is equal to n into x raised to n minus 1. So here n is 1. So this is equal to 1 into x raised to 1 minus 1 minus derivative of a constant is 0. So this is equal to 1. So it is derivative of x minus a into x minus b plus x minus a into derivative of x minus b. So from here we can see the derivative of x minus a is 1. So derivative of x minus a is 1. This is 1 into x minus b plus x minus a into, similarly derivative of x minus b is also 1. So this is equal to 2x minus a minus b. Next question, derivative of ax square plus b the whole square. Now this is of the form f of g of x. So let us take, let f of x is equal to ax square plus b the whole square. Now derivative of f of g of x equal to f dash of g of x into g dash of x. So here f of g is g of x the whole square and g of x is ax square plus b. So here this is of the form f of g of x, where g of x is ax square plus b and f of g is g of x the whole square. So we can find f dash of g. F dash of g will be 2 into g of x and g dash of x. G dash of x will be 2 into ax. Therefore d by dx of f of g of x, it is equal to, let us take this as 1, 2 into g of x. So 2 into ax square plus b into g dash of x into 2ax using chain rule. So this is equal to 4ax into ax square plus b. Next question, x minus a upon x minus b. Now this is of the form f by g. So the derivative of f by g is, denominator we have g square, numerator we have f dash into g minus f g dash. So d by dx of x minus a upon x minus b, it is equal to, here we have x minus b the whole square and then keep the denominator, differentiate the numerator, minus keep the numerator, differentiate the denominator. So this is equal to x minus b into, we just now saw derivative of x minus a is 1. Derivative of x is 1 and derivative of a is 0. So 1 minus 0, 1. Minus x minus a into derivative of x minus b is also 1 upon x minus b the whole square. Now this plus x and minus x will go. So this is equal to a minus b upon x minus b the whole square. Next question, 2x minus 3 by 4. D by dx of 2x minus 3 by 4. It is equal to 2 into derivative of x minus derivative of 3 by 4. So derivative of x is 1. since it is 1 into x raised to 1 minus 1. Minus derivative of a constant is 0. So this is equal to 2. So the derivative of 2x minus 3 by 4 is 2. Then we have next one, derivative of 5x cube plus 3x minus 1 into x minus 1. So using product rule, derivative of f into g, it is equal to derivative of f into g plus f into derivative of g. d by dx of 5x cube plus 3x minus 1 into x minus 1. This is equal to derivative of 5x cube plus 3x minus 1 into g, we have to keep it separately, plus 5x cube plus 3x minus 1 into derivative of x minus 1. Now derivative of this will be 5 into derivative of x cube. Derivative of x cube is derivative of x raised to n is n into x raised to n minus 1. So using that, derivative of x cube will be 3 into x raised to 3 minus 1, which is 2. Then plus 3 into derivative of x is 1 and derivative of 1 is 0. This into x minus 1. Then plus 5x cube plus 3x minus 1 into derivative of x minus 1 is 1. So this is equal to 15 x square plus 3 into x minus 1 plus 5x cube plus 3x minus 1. So this we can simplify 15x cube plus 3x minus 15x square minus 3 plus 5x cube plus 3x minus 1. So this is equal to 15x cube plus 5x cube, 20x cube minus 15x square plus 3x plus 3x plus 6x minus 3 minus 1 minus 4. So the derivative of this function is 20x cube minus 15x square plus 6x minus 4. Next question, 2 by x plus 1 minus x square by 3x minus 1. So the derivative of 2 by x plus 1 minus x square upon 3x minus 1. This is equal to, now we have seen one rule, derivative of 1 by f, it is equal to minus f dash upon f square. So this is equal to 2 into derivative of 1 by x plus 1 minus derivative of x square upon 3x minus 1. Here we can use quotient rule, and for differentiating 1 by x plus 1 we can use this rule. So this is equal to 2 into minus derivative of x plus 1. Derivative of x plus 1 is 1 upon f square, x plus 1 the whole square, minus derivative of, this is of the form f by g. So we have to use the quotient rule. Here we have the denominator, we should have g square, that is 3x minus 1 the whole square. Then keep the denominator, differentiate the numerator. When we differentiate the numerator, derivative of x square is 2x minus, keep the numerator and differentiate the denominator. It is 3. So this is equal to minus 2 by x plus 1 the whole square. Then minus, here x is common, so it can be taken outside. X into 6x minus 2 minus 3x upon 3x minus 1 the whole square. So this is minus 2 by x plus 1 the whole square minus x into 3x minus 2 upon 3x minus 1 the whole square. So the derivative of this function is this. Next question, if the function f is defined by f of x is equal to kx square minus 5x plus 4 and f dash of 3 equal to 37, find the value of k. So here f dash of 3 is 37, it is given. So first let us find f dash of x. F dash of x is d by dx of kx square minus 5x plus 4. So this is equal to k into d by dx of x square minus 5 into derivative of x plus derivative of 4. Now k into derivative of x square is x raised to n is n into x raised to n minus 1. So x square will be 2 into x raised to 2 minus 1 minus 5 into derivative of x is x raised to 1. So 1 into x raised to 1 minus 1 plus derivative of a constant is 0. So this is equal to 2kx minus 5. Given f dash of 3 equal to 37 implies 2k into 3 minus 5 equal to 37. We got f dash of x as 2kx minus 5. F dash of 3 is 37, it is given. So here we can substitute x as 3. So 2 into k into 3 minus 5, this is equal to 37. From this we have 6k equal to 37 plus 5, which is 42. Therefore k equal to 7. So if f is defined by this function and f dash of 3 equal to 37, then k equal to 7. Next question, if y is equal to x plus 1 by x, prove that x square dy by dx minus xy plus 2 equal to 0. So first let us find dy by dx. dy by dx will be d by dx of x plus d by dx of this 1 by x, we can write it as x raised to minus 1. Now d by dx of x is 1 and d by dx of x raised to minus 1 is plus minus 1 into x raised to minus 1 minus 1. So it is 1 minus 1 by x square, or it is 1 minus x raised to minus 2, which is 1 minus 1 by x square. Now let us consider the left hand side. Consider LHS equal to x square. This let us simplify it as x square minus 1 upon x square. This is dy by dx. Now let us consider the left hand side of this. So x square dy by dx minus xy plus 2. So this is equal to x square into dy by dx is from 1. X square minus 1 upon x square minus x into, here y is x plus 1 by x. X plus 1 by x plus 2. This is from 1. Now these two x square will go. This let us simplify. It is x square minus 1 minus x square minus 1 plus 2. So we have minus 2 plus 2, which is equal to 0. This is equal to the right hand side. Next question, if f of x is equal to root of 4 minus x square, where x belongs to open interval minus 2 comma 2, find f dash of x. So this is a composite function. So here f of x is equal to f of g of x, where g of x is equal to 4 minus x square and f of g is equal to root g. So here it is a composite function. So we have to use chain rule to find the derivative. F dash of x will be f dash of g into g dash of x. Now here f dash of g will be, if we differentiate root g is g raised to half. So it is half into g raised to half minus 1 into g dash of x. G dash of x is 4 minus x square. To derivative of 4 minus x square. Now this is equal to half into g raised to minus half into derivative of 4 is 0 and derivative of minus x square is minus 2x. So this is equal to 1 by 2 into root g into minus 2x. So this 2 will go. G of x is nothing but it is 4 minus x square. So this is equal to minus x by root of 4 minus x square. Next question, root of 2x minus 1. So let us take, let f of x is equal to root of 2x plus 1. Here g of x is 2x minus 1 and f of g is root g. Therefore, using chain rule, f dash of x is f dash of g of x into g dash of x. So this is equal to derivative of root g is g raised to half. So it is half into g raised to half minus 1 into g dash of x. When we differentiate 2x minus 1, we get 2 minus 0, which is 2. So this is equal to g raised to minus half, or it is 1 by root g. This is equal to 1 by root of 2x minus 1. Here we should have x greater than half. Since x less than half is not defined, it will not be a real number. Next question, 3x square minus 9x plus 5, the whole raised to 9. So let us take, let f of x is equal to 3x square minus 9x plus 5, the whole raised to 9. Here f of g is g raised to 9 and g of x is 3x square minus 9x plus 5. Therefore, f dash of x will be f dash of g into g dash of x. Now f dash of g will be derivative of g raised to 9. Derivative of g raised to 9 is 9 into g raised to 9 minus 1 into derivative of g of x. 3x square minus 9x. It will be 3 into 2x minus 9 plus 0. Since derivative of x square is 2x, derivative of x is 1, derivative of constant is 0. So this is equal to 9g raised to 8 into 6x minus 9, or it is equal to 9 into g is 3x square minus 9x plus 5. So 3x square minus 9x plus 5 the whole raised to 8 into 6x minus 9. This is f dash of x. Next question. Root of 3x plus 2 plus 1 by root of 2x square plus 4. Now this let us try to do it directly using chain rule. Let f of x is equal to root of 3x plus 2 plus 1 by root of 2x square plus 4. Now f dash of x will be, here we have to consider this as a single function and differentiate root of that function. So derivative of root x is 1 by 2 into x raised to half minus 1. So it is 1 by 2 root x. Now this in place of x we have a function 3x plus 2. So if we want to differentiate this, we have 1 by 2 into root of 3x plus 2 into the derivative of this 3x plus 2. Derivative of 3x plus 2 is 3 plus 0. Then plus this, let us write it as 2x square plus 4 the whole raised to minus half. 2x square plus 4 the whole raised to minus half. Now keeping this as a single function, let us differentiate this. So it will be minus half into 2x square plus 4 the whole raised to minus half minus 1 into derivative of this function 2x square plus 4. So derivative of 2x square plus 4 will be 2 into 2x plus 0. Now let us simplify this. So this is 3 by 2 into root of 3x plus 2 minus this 2 and this 2 will go. So minus 2x into 2x square plus 4 the whole raised to minus 3 by 2. Or this is equal to 3 by 2 into root of 3x plus 2 minus 2x upon 2x square plus 4 the whole raised to 3 by 2. This is f dash of x. I hope this video was useful for you. Thank you for watching.